In this lecture, we're going to be concerned with the concept of a random variable, which is a mathematical idealization of the result of an experiment. So a discrete random variable is basically a function that gives the result of a certain experiment, and you may ask, of course, it is a function of what? Well, it is a function of whatever determines the result of the experiment. This whatever is here denoted by an omega, and in the case of the coin toss experiment, it was actually the initial conditions of the coin toss, and in particular the initial velocity and the initial angular velocity. Now, we're going to distinguish between two kinds of random variables: discrete random variables, which take values that are discrete, so the values could be 0, 1, 2, 3, 4, etc., or they could be labels like dog, cat, and so on and so forth, and continuous random variables, which are random variables that take real values. Like, for example, you measure the height of a person in inches, or you measure the mass of an object, and so on and so forth. Now, even though a random variable is always a function of some kind of omega, we can often get away without explicitly showing that dependence. And that's what we're going to be doing from this point on. So a little bit about the mathematical notation here. We're going to be using uppercase letters to represent random variables. So X, Y, and Z, all capital, as you see here. And lowercase letters to represent the values of these random variables. So for example, little x, little y, and little z will be actual values. But we're not going to be too strict about it, and we may just use the lowercase letters to represent both random variables and their values if there is no ambiguity.